Hi everybody, welcome to class today, September 13th. I hope you remembered to submit assignment 13. That was a big ideas assignment. There was no work on that. We are going to go over a couple of the most missed questions here in just a moment. So if you could get your iPad out and open to that. That's going to be a challenge in this video. You don't need to open your iPad to that. I didn't think about that. But I'll go over some of them. You can look back and see if that's one you missed or not. We will have our next quiz over Unit 2 on your class 1 week from today. So whether I see you Thursday or Friday, I will see you will have your quiz then. We're going to be doing a couple of different activities next week, and you are going to need access to colored pencils. I have a box of colored pencils in my room. It will not nearly be enough. Some of the colors you want or need might not be in there. And you also will not have access to those in your other work classes, like if you have time during another class or during flex. So I would make sure you have your hands on some colored pencils. If you did not get colored pencils for intermediate or for junior high, you're definitely going to need some in all of your classes. I would get your hands on some of those. You can pick those up in the bookstore as well for a very minimal fee, but you will want to have access to colored pencils. All right, a couple of main questions that I got asked a lot about was this question on precision, really making sure you understand that the rules we learned about were product rules. So they were the product of power rules that said if you multiply like bases, there is no addition rule, okay? No shortcut for addition. So this one should be no, the expressions are not equal. Can't overapply that. The only way to solve 3 squared plus 3 to the third would be to do 3 squared, 9, plus 3 to the third, 27, and add those together, which would be like 36. But 3 to the fifth is, I don't know that off the top of my head, 81 times 3. It's big. I don't have that number off the top of my head. Definitely more than 36. Simplifying the expression, again, understanding that this means you have negative 3/4 to the third power and p to the third power, and that product to a power rule said pass that out to everybody and simplify. This is wanting you to understand that that's negative 3 to the third and 4 to the third. So hopefully we've got that we're going to have 3 negative signs, so it's going to be negative. 3 cubed is 27, and 4 cubed is 64. P to the third power. Probably the last one that was most challenging for people was the checkerboard. The row numbers are Y, and the column numbers are X's. Of the chessboard, each position, the number of pennies. So the expression is 2x times 2y, okay? And it says, which locations have 32 pennies in their stacks? Well, understanding here, this would be then 2x plus y. And then you're going to say, okay, what does x plus y need to be to give me 32? So this has you understanding the powers of 2. 2 to the second is 4, and 2 to the third is 8. So the question is, what numbers get me to the power of 30, or to get me 2 to a power of 32? Hopefully you were able to figure out that you need this number to be a 5, because 2 to the fifth is 32. And if I understand that, I would have to put those coordinates in, write the coordinates in order with the point of the smallest value for the smallest x. So all the different ways I can get to 5. Hopefully we can understand, well, the first way would be if x is 1 and y is 4, which would be right here on the board. That would be my first ordered pair. And then any combinations that get me to 5. Now, the key here is making sure you follow this part of the answer code, because I've had kids put the right answers in and then get frustrated because it gets counted wrong because they did not follow that. But the next thing I could have is 2 on the x's, and if I have 2 x's, then I would need 3, and then I could have 3 and 4 and 1. So that's where we're at on those basic connectors there. And hopefully most of you were able to determine that understanding. Okay. Then the problem went on and said, hey, thinking about this pattern, can you tell me which stack would have the tallest stack? And so hopefully if we go back here, we could think about, okay, well, this stack right here would only have 2 pennies because I would have 2 to the first and 2 to the first. And hopefully we get the understanding that back here, we would have the biggest stack, 2 to the 8th, 2 to the 8th. And 2 to the 8th times 2 to the 8th would be 2 to the 16th power, big stack, right? How many pennies is in 2 to the 16th pack? Well, again, these spots right here, they would have 32 pennies. 32 pennies isn't a lot of money, 32 cents, but they wouldn't have, they would have a decent high stack. 2 to the 16th, in order to answer this question, how much money, I need to know how many pennies. Now, some of you might have been like, I thought we didn't have to do powers over 5 or 6. I get that, and you won't on bigger than 2s. But if you know that 2 to the, if I'm trying to figure out what 2 to the 16th is, I could break this down into smaller values to get there. And that is definitely what I would do. I would not do a big old string of those, right? I would have done 2 to the 8th times 2 to the 8th. And 2 to the 5th, we figured out, 2 to the 5th was 32. So that means 2 to the 6th would be 64, doubling it. And 2 to the 7th would be 128. And 2 to the 8th is 256. So the long division, the long multiplication you would have to do is 256 times 256. And that gives you 65,536, which is what a lot of people put in here. And they were upset about that because it did not give them the right answer. But it was asking for money, so I have to remember that that moves in 2 places there. Each penny is 0.inch thick, 0.06 inch. So you got to take 65,536 times 0.06. All right, the tallest stack is about this many inches tall. 3,900 inches. I hope we're all getting that that's a pretty tall stack of pennies. I think in years past I've had my kids convert that to feet, and it's well over 300 feet. And then we analyzed the fact that it's like bigger than a football field standing up on one board. Lots and lots of pennies and a very tall tower. I'm not sure it would be able to stand. Great job on that assignment. If you have other questions when I return on Monday, we can discuss those. A couple other things we're going to do on Monday just to make sure that we all are prepared. On Monday, we are going to go over our test questions. So if you have not taken time to go over the test questions, you should do that before then. Find out problems that you don't know what you did wrong, that you want to rework, that you need to rework, and we can gladly for sure do those. Just keep those things in mind. We're also going to do an activity today, and you're going to work with some partners. We will discuss the activity on Monday. Okay, so you'll get it done today, but you won't necessarily be able to check in with it. We'll check the answers on Monday so you have the right answers to provide your check. So the question will always become, do I have to finish the activity? Well, you'll probably want those answers. I think you'll have enough time to do both. I really don't want you to start on the homework till you finish the activity today. Okay? So that's what we will be doing Monday. And don't forget, on Monday you need color pencils for the activity we will do then. Okay. I want you to take out a new sheet of paper. You're going to do notes on your own today, on your own notebook paper. So please take out a piece of paper. You're going to date the notes 9/11 or 9/12, whatever day you have class. 9/11 is when we're planning on taking these today. And we are going to simply review the 3 rules we learned yesterday. And it is important that you learn these by name. So we have the product of powers. We have the power to a power. And we have the product to a power. I want you to take a second. I want you to write those down and see if, without looking at your notes, you can write the rule, not the words, the rule, and get into that idea of what we learned in the previous class. So pause this video for just a second, see if you can write them down, and then restart. Hopefully you remember the product of power rules is when you have a to the m, a to the n, that equals a to the m plus n. Sorry, don't want to write it wrong there. If I have like bases, make sure you've got that down. If you have like bases, you can add the exponents. Because if you think about what it means, it's just how many of the a's do you have at this point. Power to a power was a to the m power to the n power says you have so many groups. And since I have so many groups, that's going to be a to the m n. And product to a power, the product to a power rule says when I have AB or ABCDE, we just write it with 2 letters, to the m power, then I pass that out, a to the m, b to the m. These are the steps you're following for each of those rules. Today we are going to learn our 4th rule, and we are going to kind of go at that by looking at the previous powers and what we learned from those. Okay, so if you want to draw a little squiggly line after your review, the actual unit, new stuff that we're going to be doing today is 2-3. It's lesson 8-3 in your textbook, and it's the quotient of powers rule. So I envision your notebook paper having a little squiggly line where you did your review, and then here are your topic and your title. Again, if I'm ever going too fast for you in the video, just pause the video, get written down what you need to get written down. I'll be checking these notes in on Monday, making sure we're working in the right direction. Okay, we're going to start a little differently. Instead of me telling you what to do, we're going to start by seeing how would you approach this. And some of you might be like, I got to take 3 to the 7th divided by 3 to the 5. That's going to be a lot of multiplication and a lot of division. If we didn't know any shortcut rules, that would be. We're going to go with my saying. Hopefully we're getting there. We're going to think about what this means. Hopefully we all got that this means 3 times 3 times 3 times 3 times 3 times 3 times 3. 7 3s over 5 3s. And then we're going to say, okay, well, if I have 7 3s over 5 3s, before I multiply all those 3s out for days on end, I am going to look at that and say, can I make this problem easier in any way? Can I simplify this in any way? And hopefully we see common factors in the numerator and the denominator, so we can say, I'm going to cancel here, and I can cancel here, and I can cancel here, and I can cancel. Now, when I'm canceling these, I'm not canceling 0. I'm dividing out a 3 from the numerator and a 3 from the denominator. And if I have a 3 in the numerator, 3 in the denominator that can cancel, I can get those down to 1. 3 to the 7th over 3 to the 5th is going to leave me with 3 times 3, which I can write as 3 to the 2nd. That is much easier to simplify than doing 3 to the 7th power, which would be in the hundreds, thousands, possibly the millions, divided by 3 to the 5th, which would give me, like, I don't even know. Can't even remember what that is. A big number, and I'd be doing a very big, long division problem. Now, there will be students on our next quiz that will forget that you can use this simplifying before you divide to help you find an easier answer. Let's try another one. If I have negative 4 to the 6th power, again, that would be an even number. But negative 4 times negative 4 times negative 4, the bottom would be 64. The top would be 64 times 64, which would be in the hundred thousands again. So let's see if we can make this any easier. I would have 6 negative 4s over 4 negative 4s. And I could look to cancel anything out, and hopefully you're saying, well, yeah, some would cancel. In fact, however many's on the bottom is how many would cancel out. So my final would be negative 4 to the third power, which would be negative 64. Much easier to simplify by canceling than simply multiplying and dividing out there. Again, x to the 8th. So that would give me 8 x's. And 2 on the bottom. I would be left with x to the 6th. At this point, I hope some of you are sitting back saying, oh my gosh, do I have to keep doing this, Ms. Kern? Can't I just use the pattern? I see a pattern. I hope you see a pattern. Hopefully you're discovering that, wait a minute, every time I do this, whatever these exponents are, just like we were doing tricks with them yesterday, or last class, we would have x to the 8th over x to the 7th, or 2nd, would leave me with x to the 6th. And that brings us to our quotient of powers property. And the quotient of powers of property says, anytime you have a to an m power over a to the n power, you can do a shortcut by simply subtracting the exponents. Again, it has to be like bases. Must be like bases. Hopefully that's sort of making sense. When we had product power, we had the same bases and we were multiplying them. We added because multiplication is repeated addition. Here we have division, and when you think about division is repeated subtraction. So it's all very much related. Now, I do not want you to have to continue to write out all of what it means. The whole point of learning the rule is once you understand what it means, being able to use that to make your life a little easier. Let's back up before we start that one. If you had x to the 75th over x to the 20th, that would make this much easier, and you would be able to tell me, hey, I know that's x to the 55th versus writing out 75 x's and 20 x's and canceling them out. That's the goal. And as you can see from our next example here, we're going to start putting together multiple rules. So I have 7 3s on the bottom. I have 6 3s and 4 3s. The first thing I should do is use my product rule to say that would be 3 to the 10th over 3 to the 7th. And then I would use my quotient rule to say 3 to the 10th over 3 to the 7th would be 3 to the third power. Notice the directions, especially in your assignment today. When you're doing your assignment in big ideas, you're going to want to make sure that you say, okay, am I supposed to write out 27 or am I supposed to leave it as a power? That will be in the directions that are given there. Write your answer as a power or write your answer simplified. You try number 5 real quick. Pause the video, and then we will look at that. I hope you got 7 to the 14th over 7 to the 10th. 7 to the 14th over 7 to the 10th would be 7 to the 4th power. When you get to this one, there's lots of ways to approach this. You could do the division first of each of these, which would give me a to the 4th. Don't divide those numbers. You want to subtract those numbers. Times a to the 3rd, which would give me a to the 7th. You also could do it going multiply first, which would give me a to the 14th over a to the 7th. Either way, you get the same answer because a to the 14th over a to the 7th is going to be a to the 7th. Now, I wrote these specifically to be problematic because I wrote powers that divide easily. And when they divide easily, sometimes your brains will play tricks on you and let you write a to the 2nd. Can't let that be your most common mistake, right? Same thing here, a to the 14th, a to the 7th. I know there will be people that'll put a to the 2nd. It is not a to the 2nd. The rules have to be followed based on the product rule and the quotient rule of the exponents. When you see dividing, you're subtracting the exponents, not dividing the exponents. Try number 7. My preference in doing these kind of problems is to always work across. So I would have had c to the 25th over c to the 7th for a final answer of c to the 18th. I think you get less errors if you do it that way. People that work down, some people might do c to the 3rd times c to the 5th and actually do dividing because these divide easily. When I multiply first, I create an amount that is not easily divisible, and that might kick your brain into, oh yeah, don't divide them, subtract them. All right, so let's put them all together here. We'll call this one number 8, and we'll call this one number 9, and we'll call this one number 10. Okay, so let's put it all together. Why don't you try the 3 of them and then restart the video to see where we're at. All right, let's do number 8. First of all, you have to do the math with the coefficients, just like we talked about on Tuesday. You have to do regular math with coefficients. You should not do 12 minus 3. If you wrote 9, you're over using the quotient rule. This should be 4. And you have x to the 6th over x to the 2nd. That's going to leave me with 4x to the 4th power. In number 9, some people get freaked out because the n and the x are switched orders. It's still looking for values of n in the numerator and values of n in the denominator. I have 3 n's in the numerator. Hopefully we all know this is n to the 1st in the denominator. When I simplify that out, I would have n to the 2nd in the numerator. 3 on top, 1 on the bottom, cancel. And then I would have x, 5 on the top, 2 on the bottom would leave me x to the 2nd, or excuse me, x to the 3rd. Some people always ask, Ms. Kearns, could I write x to the 3rd into the 2nd? And the answer to that is, of course. It's the exact same answer. Variables are just in a different order. Okay? Number 10. This is probably one of the most challenging problems of the day. This puts a whole lot of rules together. I get a lot of people that want to do 1/5 right away because they paid attention to 8. 1/5 is first wrong answer because I have a product to a power here that I must do first. This problem's second layer of work should be 3 to the 3rd, x to the 5th to the 3rd over 15x to the 4th. That would be simplified to 27 x to the 15th over 15 x to the 4th. And then that simplifies as well. 27 over 15. This is where a lot of kids are like, oh, I get this x to the 11th. That's awesome. But I'm just going to leave it 27 to the 15th. The rule is still simplify. Are there common factors in 27 and 15? And the answer to that is yes. They both contain a 3. 27 divided by 3 would be 9, and 15 divided by 3 would be 5ths. 9/5 x to the 11th. We're going to keep doing more and more like those, getting you on track. We are going to practice, and you're going to practice together now that you've finished those notes. So once you finish the notes, you are going to get with a partner that's finished. So you'll need to be looking around for somebody that's finishing about the same time as you. You can work in groups of 2s or 3s. Okay? You're going to put activity 911 at the top of the paper. It's going to go in the activity section of your binder. If you're doing this on the 12th, you'll put the 12th. When you are finished, that's where you will house that. You're not going to submit it. We're going to talk about it on Monday. How I want you to complete this is I want you to start on side 9-2, and I want you to do the first 2 problems together. You have answer banks. You guys can bounce off ideas of each other. Hey, is this what you think? Yeah, that's what I think. Oh, I think we're in the right. All of that as well. Then I want you to turn the page over, and I want you to do 2 problems on the back. I think when you do a whole bunch of problems of the exact same nature, you kind of get into a rut and be like, this is what I always do. So that's why I want you bouncing back and forth. So then you're going to do 2 on the back, compare, 2 on the front, compare, 2 on the back, compare, 2 on the front, compare, and so on till you finish. Okay, we will go over this in our we will discuss them in a group on Monday. I want you to do your best. If I'm in class, you can ask me some questions, but you can work with your partners. You can talk in your groups. Once you have all of those completed, you're going to begin work on assignment number, I don't even know what number we're up to because I'm not good on my plan book here. Let me check. You will begin work on assignment number 14. And assignment number 14 is your online practice from lesson 8-3, 70% or higher. Submit a screenshot of your score. Once again, you don't have to do any work. You might need some paper to do some of the scrap calculations, but you don't have to turn in any work paper, just your answers. Great job today. I will see you in class on Thursday or on Monday.